Hello everyone. This video is going to review the noble gas or shorthand notation. Remember that the noble gases are in group 18. It's the group all the way on the right hand side of the periodic table. The first thing you need to do when you are writing shorthand notation for the electron configuration of an element is figure out which noble gas you're going to start with. And the rule for that is that you want to go up one row and then all the way over to the right to get to the noble gas. So for example, I'm going to go through the electron configuration for element number 39, yttrium. So the first thing we need to do is to decide which noble gas we're going to start the configuration with. So we go up one row all the way over to the right, and we see that krypton is the next smallest noble gas. And the noble gas, or the symbol for the noble gas, is always put in square brackets. So for yttrium, we'll be starting with Kr in square brackets. The next piece is to figure out what is the next subshell that is going to be filled. The way to determine this is, notice that we have the numbers of the rows along the left-hand side of the periodic table. Whatever the number of the row is that our element is in, it is that number S sublevel that is the next to be filled. So for example, yttrium being in row 5, the next sublevel that is going to start to be filled at the beginning of row 5 is the 5s level. Notice also that yttrium is atomic number 39, krypton is atomic number 36. So after using the krypton configuration to start, we need to figure out where 3 more electrons have to go. Like we said, 5s is the next subshell that starts getting filled, but that can only fit 2 electrons. So we need to determine which level the next electron, the 39th electron in yttrium, goes into. And just like with any other configuration problem, figuring out what the next subshell is, we're using the Aufbau principle, which is shown by the diagonal rule. Looking at the diagonal rule, we see that after we fill the 5s sublevel, we need to go to the beginning of the next arrow, which is at 4d, and so that next electron will fill one of the 4d orbitals. And so the shorthand notation for yttrium is krypton 5s2 4d1. And we can see why this is a much shorter way of writing the electron configuration of yttrium than doing the longhand notation. The longhand notation, we would have had to write out 1s2, 2s2, 2p6, 3s2, and so on, all the way through these last 2 sublevels of 5s2, 4d1. Using the noble gas or shorthand notation, we're able to eliminate a lot of that writing. We use the noble gas that is just 1 row up to start the configuration, and then again we know that the next sublevel to be filled is the number of the row S sublevel. As another example, let's say that we want to find the shorthand notation for arsenic. So arsenic, we look up a row all the way over to the end, and we see that argon, atomic number 18, is the noble gas that we're going to start with. Arsenic is in row 4, so the 4s sublevel is the next one that will be filled. And notice that since arsenic is atomic number 33 and argon is atomic number 18, that means that after argon, we need to find where the next 15 electrons go. So we start with the 4s sublevel, that can fit 2 electrons. We then see from the diagonal rule the next sublevel to be filled is 3D. D sublevels can take 10 electrons. Remember, there are 5 orbitals within a D sublevel. So we would have 3D10. That gets us to 12 electrons. Remember, we needed 15 more. So we go to the next sublevel of 4P, which can take a maximum of 6 electrons. And so the 3 electrons remaining will fit into that sublevel. And so the shorthand notation for arsenic would be argon 4s2 3d10 4p3. So to recap the steps in the process, first, as with any of these problems, we need to find the element on the periodic table. We then go up 1 row all the way over to the right. And this is the noble gas we start with. We want to find the difference between the atomic numbers of the element and the noble gas. Because that is the number of electrons we need to add into our configuration. And then the next sublevel to be filled is the S sublevel of the number of the row that the element is in. And from there, it's just like any longhand notation or really orbital diagram problem. We're then applying the same rules that we would as usual in order to determine what the full shorthand configuration is.